Welcome to this BiofilmQ tutorial. My name is Hannah and today we're going to have a look at the advanced options in the Visualization tab. So in previous tutorials you have already learned how to load data into your workspace here, as well as how to perform plotting with the different plot types in this drop-down menu here. Today we're going to discuss how to use the advanced options, which allow you to apply custom scripts on your data. These custom scripts are Matlab scripts, and if you want to edit and change them yourself, you will need a Matlab license as well as Matlab installed on your computer. I will now show you a short example that will motivate us for how these advanced options can be used and how they can improve your plotting results. Remember that the sample directory that I have loaded here contains two biofilms growing together over time, and that we have two channels, one of which is displayed green in this merged view here, the other one is displayed red, and that one of the biofilms expresses a fluorescent signal in both channels, whereas the other one expresses a fluorescent signal only in one of the two channels. So what we want to do now is we want to have a look at the image cytometry properties by plotting channel 1 versus channel 2 on a logarithmic scale to see if we can separate these two colonies. If I perform the plot, you can see that a lot of points have been plotted. So many that we can't distinguish them anymore, and we can kind of guess that there are two populations of cells, but they are hard to distinguish because everything's just blue here. The points are so dense. In order to get around that, we will apply the script that we provided together with BiofilmQ. You can click on Apply Custom Script on Plot in the Advanced Options now and click on Browse next to it. And open will a dialog where you can choose which scripts to apply. And in this case, we will choose Scatter to the color points according to point density. So this is an example script that you can apply on your data, which helps you to, for example, in this case, identify dense areas in a plot of points where the points are so dense you can't distinguish them. And now we can much more clearly see our two populations of cells. So this is one example on how to use these custom scripts. We will now look at two other examples which are simpler. So I can walk you actually through the Matlab code so that you can understand how it works, and maybe you can apply it yourself with your own wishes and needs. So I'm going to open Matlab now. You can see here I have already opened these two scripts, example modify data script and example modify plot script. We will start maybe with the example modify plot script because it's a little shorter and therefore maybe easier to understand. This can be applied after plotting. So at this point, you already have the plot and you have these handles H and HX for the figure and the axis. So if you now want to make any changes to the figure or its axis, you can use these parameters, these variables here in the workspace. Now what we're doing with this script is to simply add a horizontal line. We do this by determining in H-axis that the next plot will be added to the figure instead of override the previous content of the figure. Then by taking the x limits of the H-axis, we find the limits of the x-axis, which we will then use to perform the plotting. So the plotting here is this one line where H-axis is the object that will be plotted into. X limits are your x values. These are your y values, which we set to 5000 because that is where we want to put the line. And then this part back here determines what your line will look like. It will be a dashed line in the color black. In order to show you how this example works, we will now make a very simple plot, the 2D XY plot per frame, where we want to plot time on the x-axis and cell number on the y-axis. We will uncheck the two log boxes and set the method for the range to min-max in order to see everything. Again, we will go to the advanced options panel down here and now choose a different option, which will be example modify plot. Now I'm going to click on plot again. And you can see my cells growing over time. And you can see that now at 5,000 a dashed line has appeared. And this is the line that we added by applying our custom script on the plot. Now for our second example, we will have a look at the data prior to plotting. And what we will do here is we will shift the time point. You can see that my time point is every 2 hours roughly. Going back to Matlab now and looking at the other script. So what we want to do is we want to shift our time point by 1 hour, so 60 minutes. So we define this variable 60 for the time to be added. Now in order to understand what happens in this loop, I need to show you what the variable biofilm data looks like. So biofilm data contains all the information about your segmented data and all the parameters that were calculated for it. I will now open biofilm data. You can see it has a number of different fields. We will go to data, and here for each file in the file list, we have a number of columns that contain information. We have, for example, the timestamp at which the image was taken, the image size, the number of objects, which means the number of cells. And then we have these more complex variables back here, where stats is the one we're most interested in. Now, stats represents all the parameters calculated for all of the cubes at this particular file or at this time point. Every row corresponds to one cube, and every column corresponds to one parameter that has been calculated. So you can see we have, for example, the volume of the cubes here. We have the mean intensity integrated of channel 1 here. So if you manipulate this variable biofilm data in your workspace, you will manipulate your data prior to plotting. Note that this variable biofilm data will not be saved to a file. So when you reload it, it will be reset to its original values. Therefore, you can't make any mistakes. If you believe that you have done something you shouldn't have done, you simply go back to the GUI, click on load data, and it will reset. So now what is this loop doing? It's a for loop that walks over all the different time points in biofilm data. So this one here, so it walks over all the different files, and for each file it goes into this stats part, takes the time and adds these 60 minutes to it. So this part here is how you take the information of time for all cubes out of it. If I only copy this command here to the workspace down here, which you can also do at home, I replace this frame by 1 because the variable is not set. If I now click enter, you can see these are all the time points. In this case, they're all the same for each cube at my first time point. If I want to look at my second time point, I change this number here to 2, and I get the time for my second time point. If I want to look at another parameter, for example, the volume, I change this word here, time, to shape volume. And now you can see it's different for all the different cubes. So this is how you get access to the variables, to the parameters calculated for each cube. And by getting access to them, you can also manipulate them. And you do that by overriding. So here we override this value for time for each of the cubes. And now, because time is also a global variable, we also have to override the time point in our global intervals. And we do this again for every frame, for every file in my file list. So now, if I also apply this script by clicking on Apply Custom Script on Data and browse, and I pick Modify Data Script, you can see that my time points have shifted. We no longer start at 0, but we start at 1. And if you compare the table of time points here to the position of the points, you can see how they have been shifted. So this is how you can write MATLAB scripts in order to change your data prior to plotting or in order to modify your plot. And you can now get working and write your own MATLAB scripts and see what you can do to make your graphs look nicer. In other tutorials, you can learn about, for example, the filtering gating option, or you can have a look again at the different options for plotting.